let's see. Yesterday we barely scratched the surface of refactoring Rigidbody 2D, which is a player controller using Rigidbody 2D rather. We have seen a lot of horrible code, mainly badly written comments, and we are in the process of fixing that, upgrading it, making it renewed for Godot 3.3 and not for 2.2, which was the time when this code was originally written. Currently it works, but it's not great. Jumping, for example, it looks almost completely diagonal. It doesn't seem to be a curve almost. I mean, there is a curve, but it's barely visible, so there's a lot of work to do here. Well, I hope there won't be a lot of work to do, but there's work to do. Since last time I did a little checking to research a little bit about static Rigidbody 2D and whatnot, and the uses of Rigidbody 2D. And the main purpose, the main reason to use the Rigidbody 2D as a body for your player is if you want your player to be can be affected by environment like gravity and physics outside of the player. So if you want more of a goat simulator feel where anything can happen based on physics, Rigidbody is for you. However, if you want to make a player in a game, 2D game, or 3D, you know, well, I guess kinematic is only 2D, maybe. But if you want to write a player and have control of that player, kinematic body is way better than using a Rigidbody 2D. Because it gives you the control. Nothing will affect the players unless you tells it to. Let's see, not this one. What can we find here? There was some example code I wanted to look at. What example is this? A thrust? Is this like a space shooter game? You have a thrust, which is a vector. You have torque, which is I think it's acceleration in rotation. Input, when you press up, you then set the applied force to thrust.rotate the rotation. Yeah, there's some rotation for sure. Okay, this is not a good example for us. Maybe there's something else we can look at. Let's see. Move and collide. Does that work in kinematic body? Yeah, this is kinematic, right? Yeah, that's way better than Rigidbody, so let's not go there. Let's go back to our code now. It doesn't seem to be too much more we can do at the moment. Let's just clean the code we have and work from there. Last time we removed the character GD, which the player script originally inherited from, and we don't want that because right now we don't need it. That's a waste of code. It's code you don't need. And deleting it, how do I do that? Let's see, where is it? There, no, not there. There it is. Remove. Let's see, we need to clean this up. This is a mess. To do, move the speed diagonally uphill as well as downhill. Accelerate on-off switch. Okay, I'm leaving that there because that's something I would like to get done in this script before I update the tutorial and whatnot. We have speed, acceleration, top move speed, top jump speed, and a jump speed. How can we clean this up? How can we make this more reasonable? If I could just dream some code that doesn't exist, how would I write that code? Currently, when we run the game, when the player is loaded, integrate forces keeps looping. It keeps running. And the first thing we do is we apply force to that body. And that force is applied depending on the input, and for some reason we check grounded in here. Why do we do that there? Yeah, that shouldn't be here. That should be out here. It doesn't belong here. And that means apply force is redundant, because apply force is just handle input wrapped, or it's wrapped function of handle input. So let's remove apply force altogether. and make sure that works. It works as before. Excellent, excellent. So now we integrate the forces, we handle the input of the user. And the way we handle that is by updating the directional force in all the ifs except the last one. If action just release select, then can jump is false. So what is can jump? What does that really do? It prevents us from jumping again in the air. That's what it does. But this is not a really good name, is it? Or rather, this combination of code is not great, because it's difficult. You wouldn't know what the hell this does unless you know the context of this code. What this piece of highlighted code does is prevent double jumping. So once you stop jumping, after you click the jump button and you stop jumping, you stop pressing the button to jump, you can no longer jump again until this boolean is reverted to true when you are grounded. So why do we have another boolean called grounded? What's the reason for that? Why do I use this? Why can't we just use this? Right there. Right? I mean, maybe there's a reason for that. Maybe it isn't. Let's try to change it and see if we can't make it better. But check grounded. I don't need to check grounded separately. That can be done when you get here, right? Because you have to set this true anyway, so why not just set jump time to 1? Make it reset. And that should hopefully remove the need for this altogether. Which means we don't need this junk method here. Hello, Mr. Just the Reborn. Welcome. Yes, we're continuing. Fixing code. Let's see if this works now. I just removed the hopefully redundant function that does double code. Aha, it works! Excellent, we cut down the code, the number of lines. And we enhance readability by doing so, because now we have all of this in one place. But we do have some repeating code here. I'm wondering if we can make this a bit easier. Like this part here, this is details I don't care about. When I want to see the function, on ground, check, body enter, which is a signal attached to the player's collision, what's the name? Area 2D. Right? Yeah, there it is. It will fire up when we hit the body ground. So how can we change that? What if I could just do this? If collided with ground. Wouldn't that be great if I could just do that? It's way more readable, right? And we'll send in the body there, because we probably need some information about who we're colliding with. And in here, we can then add a collided with ground. And then we'll take in the body and paste in the code we had here. And what we will return is this. Return groups has solid. So in effect, this should have the same effect as doing these two lines, but with a better name which describes what you're doing. So let's copy this, use the same one here, remove that, and test it. And it works. Excellent. And I cannot double jump. Already now, the code is looking a bit cleaner, a little bit, you know, one step at a time. We have calculate movement velocity. What does this do? This is the code part which we haven't quite figured out the way we wanted to. At least I haven't figured out the way I wanted this to. Can I do this? Am I allowed to do this? I would like to have multi-line. There should be a way to do that, shouldn't there? Maybe if I move the plus down there. Ah, excellent, it works. Not. Never mind. Why doesn't it work? Let me undo that. Okay, that was strange. By doing this... Oh, I see. What if I do this? There should be a way to make a like a continuation line. but I don't remember how. Let's see. Maybe I can search that information. Godot Engine. Code line, new line. I don't know. Search for here. Ah, long code into multiple lines. Okay, so we use this one. Let's try it out. There we go, it works. Excellent. So this is definitely something I want to work with. What else? How else can we simplify this without losing functionality and without making it more difficult to read and easier to maintain? When we integrate forces, we handle the input somehow, and in the handle input function we are setting values. We are setting direction of force. We are incrementing jump time. So we have this one and we have this one that is being manipulated by handle input. What else do we have? We have can jump as well. So let me move that down here and group this together so it makes it a bit easier to see what we're using, what we're working with, so we can take that out. Let's see, movement velocity, it's localized only to this part. Now this here may be a function, but let's stick with this function first. If no input is selected, this is what we're gonna set by default. Every time we run this code, it's gonna be set 0, unless we press a button. And the way this is set up, you can press both left and right button at the same time, and all this is going to do is it's going to nullify each other. I believe, or would it be 1? Yeah, it's gonna nullify each other because it's gonna be -1 + 1, and that's 0. So it's not gonna, it's the same as not moving. So the functionality of this is fine. We have input EUI select press, which is your space bar. And when jump time is less than top jump time and you can jump, then something happens. This code here I want to fix. This is not very friendly to read. Now can jump might be a boolean that should have a different name. Enable jump. How about enable jump? Or jump enabled? Because can jump and jump enable are slightly different, but different meanings. Because if jumping is enabled, that means you can jump, but it doesn't mean you are jumping. And can jump, I mean, I guess it's in a way it's the same. However, can jump seems more suitable to be a function name right there. So if I press the space button and can jump, right, that seems way more friendly than having a boolean named can jump. So let's see how that turns out. And then we'll just return the value, the result of this. If jump time is less than top jump time and can jump is true, which we're gonna rename to jump enabled. Let's make sure to get all of these. There are quite a few places where this value has been set, and it's very easy to lose some of them. There it is. That should be it. Let's run this by pressing F5 and see if it works. And it does. Excellent. So now when you go through the code, we are setting the initial force to 0. If you press left, you add left. If you press right, you add right. If you press UI select, which is a bad name in itself, who knows what select is? We know it's jump. So what can we do? Maybe we can do this. Maybe we can mask this somehow. Let's leave this for now. This should be a different name. I would probably just use create an action or a key word called jump. But the reason I didn't do that is because during the tutorial I didn't want to waste time setting up the action names and whatnot. I would rather focus so anyone that boots up this project can run this without setting up their own keys and whatnot if they were to follow along. But this is definitely an improvement, because now I can see right away. If I press this button and I can jump, then we do this thing, which is what? We add up to it. Great. And then we increment the jump time with the body state get step. Now get step, I have no clue what this does by itself. I think this is some sort of delta. I don't know if that's true, but that's what I would think right now. Let's see if we can't add some, check what it is. Yeah, the time step delta is used for simulation. So it's the time between the last time. Now why they wouldn't use delta or something, I don't know. And when you release it, you turn off jumping, because if I didn't do that, I could just keep jumping while releasing. Keep jump. Can I? Hold up. No. Wait a moment here. No, I don't need this. This is not needed, because we have something called on ground check body exit. When you leave a solid, which is a ground group, hold on, something is strange. On ground check body exit, and if you club with ground, why would you enable jump again? You know? That's strange. Shouldn't I be able to just jump forever now? Ah, interesting. Something is broken here. Okay, jumping. Okay, I can jump. Pressing space a lot. Oh, interesting. I can fly almost. There. I have a double jump there, but I suspect it has nothing to do with this one. Let me take this to false and see what happens. There we go. Interesting. Okay, now this is fixed. Hopefully we shouldn't need this anymore. Or should it? The idea was that when you hold down the jump button, you would jump higher until you release it, until you reach a max jump height. But let's remove that. Control K that out. Yeah, this works fine. But now I don't think I can hold it down to get a different height. The height is now constant. Whether I press for like half a millisecond or something, or hold it down, the height is the same. And I believe that was the reason we had this to begin with. But maybe at some point I changed something that removed that functionality. But let's remove that for now. We don't currently need that. Collided with ground. But I realized something. This name is not quite right. Collided. Because what this does is check is whatever body we are interacting with in a signal is a solid. It doesn't check if we collide it checks if we have interacted with it. So maybe a better name would be interacted with. So when the on ground check body exit interacts with this body, the ground, then we turn off jumping when we get here. Let's also make sure to update the function name. Let's see. Do we have any classes here? Do we have objects we can extract? Because that's what I really wanted to do. Now this constant belongs only one place. It belongs in here. So I'm gonna move it there. What else? Speed belongs where? Speed belongs in there, so I'm gonna move it there. We don't need it. We don't need to expose this to the world yet. Make it simple. We have jump speed. Whereas who owns jump speed? Apparently, they calculate who owns that as well. So let's also move that one in there. Acceleration is owned by, guess what? The same function. Let's move that in there. What else? Top move speed. Who owns that? Apparently this owns that. But this does a lot of things. We are calculating movement speed, rather the movement velocity. We are then clamping it so it doesn't exceed a certain value. So the velocity we set doesn't exceed something. and then we set it. How can we... What would I name this? If I were to write this out, what would I write that this is doing? This is setting movement velocity. Right? But we're doing more than that. We're also calculating it. So maybe this shouldn't be here. Maybe this should be like here. We calculate and then we set it. So already we apply movement velocity with some validation or restrictions, I guess. I think that's fine. Let's just send that in there. Let's create this function. Let's see. Body state, where that's received in there. Okay, let's send that in as well for now. And let's see if we can't make use of it. But yeah, no. We can... It doesn't have to be this way. This can be here, I realize. Because then we don't need this. We would only need this. And what this is to, it would restrict the movement speed. It would clamp it to acceptable values. So in reality, we would just set the movement velocity to whatever value this would, to whatever this would do. Now I'm a little curious because I don't remember if Godot, if it's gonna send in the same reference to the value or if it's gonna create a new reference when I return this. And the reason I want to return this because I would like to keep this somewhat functional, at least in theory. Just gonna show movement velocity. Let me fix this. This is movement velocity, velocity. There we go. Now I should get the values, I think. There's a... then I'm going to calculate the acceptable values from this. Actually, you know what? Let's get the x and y values from that. Yeah. Empty zero, empty velocity. We then set the x and y value. Actually, I don't need that. I can just make it empty. So we're creating a new velocity object, which we will use the values from x and y to restrict the move speed to negative to positive on both the jump and movement speed, and then we're going to return that, and we're going to set this to the new value. Why am I getting errors? Because I'm trying to use a body movement, body state that doesn't exist yet. Okay, so now we are handling input, we are handling the movement velocity by using the body state. We are then applying movement velocity. Oh Jesus. Okay, how about this? Restrict movement velocity. Normally I wouldn't spend this much time on function names and whatnot. I would spend time on it, but I wouldn't go in such an excess, because that's it can be a waste of time if you don't have time. Restrict velocity, and then we set the linear velocity. But now these two things are doing something. Let's take a look at calculate again. What are we doing here? We are calculating the velocity based on the body. But what does the sum of these two do? What does these two do? Because what I would like to do is I would just like to call a method and get it directly here. But let's leave it at this. Let's see, handle input. Have these variables it uses throughout the code, and some of them are shared. Can jump is used in here, and on ground check body enter. How about jump enable? Where's this used? This is used in here in the calculation of whether or not you can jump. It's used when you set them. Okay. So grounded, is that in use now? It's not, so let's remove that also. Okay, this is a little better. It's not great, but it's a better. Jump time is fine, that's a good name. Jump enable is also a good name. Let's move this up now, I think this is fine. Let's see, hello Slacks, welcome. So wow, when we integrate forces, we handle the input first by checking the input and set the values to whatever we need them to be. Then we calculate the movement velocity by using the body state, and what we use from the body state is to get the linear velocity. So let's change it. I don't need the entire object of body state. What I need here is just a vector 2 that will contains that velocity. So how about this? Body velocity. So in that case, I wouldn't need to know about this. I don't need the body state. I can just use the body velocity and return that directly. That means I would have to get the linear velocity here. And that way, it makes it a little bit easier to follow the flow, to figure out what you're using here. We handle input, the body state, it sets the directional force. There's nothing else that seems to be setting this force. And where's this force used? It's used in calculate movement velocity as well. It seems to be only in use here. Why am I using a shared variable though? Is there a reason for that? I don't think I need to. I think this can be set in here because it doesn't need to be persistent in that way, because we are setting this every time this run anyway, in which case we could easily just do this. But this needs to exist in this scope because the calculate movement velocity is using it. So what if I just return this? I did play around with this yesterday. I didn't get anywhere with that, but maybe now we can. In which case, let's remove that one. Let's make sure whatever needs this gets it, and that will be in calculate movement velocity. It needs the directional force. So jumping down to this function, it will need directional force, which is also just happen to be a vector 2. And that way, everything should roll, everything should work now. Famous last words. And it does. It works perfectly. Jumping is fine, moving is fine. There's still an issue about the movement speed when you go diagonally. You notice that on a horizontal plane, the speed, the velocity is restricted to 183, negative or positive direction. But when you go diagonally, it exceeds and it's less than the maximum speed. And in most games, you probably wouldn't want this. And that's why you should use kinematic body 2D and not a rigid body 2D when making a player controller. Like really. But let's see if we can't fix that somehow. I have no idea how to do that just yet. I may have to change the collision with the raycast or something, and then apply the forces parallel to the ground. So when you are in the diagonal, the force is going upwards diagonal with the ground. So when you're on the flat ground, it's going horizontal to the to the ground, whatever. Unless you're going on the wall, I guess. So we probably would need a max angle checker or something. But we'll get to that. It's not too difficult, but it does require a little thinking. A programmer's worst nightmare: thinking. Oof. Yeah, you know what? This is fine. But this is not a great name now. What we're doing is we are handling input, but the result of our handling input is to apply a directional force. And creating it and applying it and returning it. With the addition of manipulating the jump time, which is another top level variable we have here. Which is used by can jump and the signal checker. So we can leave that for now, and we can also leave this one, I believe. And yeah, because it's also used on a signal. Let's see. Get directional force from input. Would that be a better name? Maybe a bit long. But would that be more understandable? But input can be misinterpreted as this value, which is not the case here. The only thing we need from this value is the step, which means we don't need to send this value in here. What we need is, we need to get the jump time difference. But do we even need that in here? So many possibilities. Let's just change this by getting the body step for now, and see where it'll take us. And let me extract that. I try to avoid using method calls within method calls. Now this is not an extreme by any means, but I don't need it. It doesn't make it easy to read. But it does make it easy to refactor, because you can visualize the flow without having to go into each and every function. Okay, so these two are part of calculate movement. This part is only a part of directional force. What else do we have? We have movement velocity, we calculate it, and then we restrict it. Maybe restriction should be a part of the calculation, because in a way it is. We calculate and restrict it to the values we want, so it is a part of a calculation, or two multiple calculations, I guess. What did I removed something here. What did I remove? Body step. There we go. Make sure it works. It does. Excellent. What else do we have? We have linear velocity, directional force, and body step. Body state, body state. We're currently getting the body state for two variables, which we are setting on the function, or rather in the function. Then we are doing this part. This should be in here, so let's move that in there. Let's move that below this one. Someday I would look into creating a plugin for Godot that will automatically sort the function calls from a high level to a low level. That would be nice. What that means is that when the top function, the main function of that class, or this script rather, will then get the functions posted in the right order of execution. For example, if this is the function of this class, which just happened to be private because it's or rather protected, I guess is a more correct one, but it's indicated to be a private function that shouldn't be called by anyone. But the order of functions would then be this, then we'll get this one because this is the next one in line, and if this calls any functions, then there will be a function below that one again. Then we have calculate movement velocity, which would be this one. This does not. Oh, here it is. Yeah, this is part of this. I don't like these though, but maybe we'll get back to it. Restrict movement velocity. That's fine. ground check. It's fine, it's fine. Interact with the ground though. That's also fine, yeah. I'm not a fan of the prefixes to indicate private and public. I believe Godot is gonna get something, something like this in the future. If I'm not mistaken. I think I read something about that. Let's take a look, shall we? Godot Engine, private, public. Maybe there's something here. It's not about private public. Okay. Interesting. Oh, cool. Oh yeah, they did change that, didn't they? I've completely forgotten that. Cool. Oh my god. Now this here is an example of too much. There's too much in one place. There's so many variables that probably shouldn't be on the level of script. Maybe there's some gold nuggets here we can take inspiration from. Let's see. Gravity calculations. Why are you doing gravity calculation on a kinematic? That's why. Okay. Well, it's good. It's kinematic though. That's good. Yeah, screw it. I think this is fine for now. I think I need to get back and take a look at this again for further inspiration later on. If I stare at this for too long, I'll get colorblind. Let's see. Let's add some explicit returns. Vector 2. Body step. I think that's the right one, right? Oh wait, this is wrong. That's wrong. Body step is a float because it's a time difference. Can jump returns a bool. That looks fine. Restrict movement. This is the vector 2. Body. Yeah, what is a body anyway? Let's take a look. Area 2D. Area enter area 2D. It's a body, right? It's a node. Oh, interesting. Yeah, because we don't really know what it is, do we? It can be anything, as long as it's a body. Or really? Okay, whatever. I just wrote body. I meant to write node. That's my mistake. Okay. Let's see. Okay, what I'm going to do is I'm going to commit this to a branch. I'm going to ask for some feedback and opinions, and hopefully strong criticism that can help give us ideas of how we can make this better. I'm thinking that the next step is to create an object, a class of sort that would do some of this logic. Now what that will be, I don't know. Not yet, at least. We do have some calculation of movements and whatnot. Well, I know 2D is possible too, I guess. I don't know. What the hell? Did I write 2? It probably would work. I'm just following the documentation of the area 2D though. But that's a good point. I don't know why they expect only a node. Maybe there is ways to combine the nodes, 3D nodes rather, with 2D. I don't know. Now, if an area is entered, we do expect area 2D, so that is interesting. But when a body enters, it seems to be expect a node. Yeah, that's really interesting. I don't know. That's a good point, though. And that may be completely correct, I don't know. Okay, let's commit this. Let's do a quick review of the entire project to make sure I haven't forgotten something. The player script is okay for now, there's still a lot of stuff happening. The player class, or rather the node, is fine. We have a collision, we have a ground checker, which is one way of doing it. I would like to add a ray cast so we can move in the direction we want to move. Actually, you know, maybe I should do that. What time is it? I still have time. Let's see. And what that will mean is when I move on this plane, I would want to change the force. I don't want the force to go horizontal. I want the force to go with the hill and not exceed or be less than the speed you expect. I expect 183 in speed in both directions, like we do now. Also here. You know, let's do that. Why not? Let's do that. I think I can do that with the ground checker also. I think there's data here I can use. Can't I? Let me do some searching. Godot Engine, body, get the angle. Determine the point of collision. Maybe that's something we need. State, get contact local position angle, get contact local normal angle. Woohoo, yeah. Look at this. Look at this. Beautiful. Body enter. Even better. That's what I wanted to use. Oh. Yeah, you're absolutely right. That's an issue we have. Because when you use rigid body, the force is with you, and that's a negative thing when you want to control the player, which is why I recommend kinematic body. Unless you have a specific reason to use rigid body 2D, I would recommend kinematic, because that gives you the control. You will not be affected by wind and weather unless you wanted to. If you are using a rigid body, you have no say. You may, you know, counteract those effects, but you have no say. It's gonna affect you. If a body meet a body coming through the right. Hold on. What's that a quote from? Contact. Yeah, but that's a good question though. Or you can use rigid body 2D body enter signal. I'm confused. What is determine the point of collision? Body get position. Go position. You know, that could work. Yeah, kinematic body 2D is king! Maybe we would have to use this one. But I don't have any control here, do I? For all I know, this could be a wall or something. You know, let's try this. Let's try it out. Let's do some quick following. But before I do that, let me commit this. Let me add a commit. Let me create a git. Did I forget to add a git ignore? I think I did. Yeah, I did. And what the git ignore is going to do is going to allow me to hide the code we don't want to commit. Let's see. Is that right? There it is. Godot. Create. Thank you. New text document dot git ignore. Hopefully it's going to allow me to. It's not. Yes, well, it's not. That's fine. I don't mind that. Godot. Yeah, it looks fine. Let's save that one. Catch you in the eye. God. Let's see. I have no clue what that is. I'm sorry. It's git add. Git commit. This is locally. I have not committed this to a repository yet. Initial changes, I guess. There it is. Git, there we go. Let's now fix things. But that means we have to change the way we calculate the movement velocity. This is fine. All of these are fine. I think. You know what? That depends. Yeah, no, I have to rotate the velocity. That's all. That's all I have to do. But I cannot affect the. You know, this is a tough cookie because the way we're currently doing this, we are merging the horizontal movement as well as jumping in one variable, and that's not a good thing here because it'll it will make jumping complicated when we reuse the same code in such a way. My fear is that when we now calculate jumping in the same function as we would do any movement, is when we then go on a slope, we're gonna jump kind of horizontally, diagonally, and maybe we want that, I don't know. But it's definitely an issue. I would probably want to separate this, but that means a lot of refactoring again. Okay, before I do that, let's just find a spot to do changes here. Let's do the test here. Let's see. Let's copy this and see how this would work for us. If our body state has contacts count above 0, so we're touching something, whatever that is. This is not a great way to do this. I don't want this. I don't like this. Angle. There has to be a way to do that from the collision checker. I'm sure of it. I guess I can calculate it manually. Because we can get the body goal position or the position. And then we can check the angle to that position. But again, not great the way we have done this. Let's see. This, I want to change this. This should not be a force at all. This should just be a directional indicator. What we're pressing, a button check, input checker, something like that. And using this information without combining this with the calculation of the velocity, we can then separate the horizontal and vertical movement, or combine it when you're walking on the ground. But when you jump, you apply a separate force on that player, which goes up, which is not affected by, you know, angles. You know what? Hold on. Why am I doing this? I think there are probably some test code I can look at there and see. Maybe there's some player controller I can use here. Let's look at this one. What's in here? This is a kinematic body, useless for us. That's a shame. You know, I guess we can just create a raycast. I think that's the easiest way to do this right now. A raycast 2D, and that's gonna check the ground. So whenever this collides with, it's the ground somehow, somewhere. Keeps the previous velocities when you jump on a slope. Maybe. I don't know how this is gonna work together, to be honest. I'm probably overthinking this. What am I doing? These are all wrong. The Godot convention looks like this. Hopefully it's not gonna break anything. Make sure it works. Works, excellent. Now the naming of the classes, the files are fine. They are following the convention of Godot. What about the main scene? Hold layer. Speed. That means I have to change this one. Use a upper capital P. let's try it again. Yeah, you're right. I'm thinking you're probably gonna bounce a bit when you jump on the slope. And that's one of the downsides by using rigid body. I would never use rigid body on my own projects. Oh, boing. It's a little bouncy, a little bit. I don't know, it feels a little bouncy. Let's see. Yeah, you can see a little bounce there. Tiny bounce. It's very difficult to see, but it's there. Okay. Let's go back to the player script, take a look. Let me commit this one more time. Git add, git commit, updated naming conventions to be followed. Now we're gonna mess up the code. Yeah, kill it. Sorry about that. Hopefully I didn't kill any eardrums. Okay, this is not gonna be a force. This is gonna be direction. Get direction. Get direction from input. That's what we're gonna do. Nothing else. Besides, Cal didn't jump. No, no, no. We're not gonna do that. This is a jump. It doesn't belong here anymore. We're gonna take that out. So now we are really getting the direction from input. Because if you press left, you add left. Because you're pressing left. If you go right, you press right. If you go jump, you go up. You can also go left and up. That's fine. It's just going to be in vector x of value 1 and vector y on the value 1, which means those two values tell us we're moving one direction and we're jumping. Key is jumping. So how do we do that? Now I need to do some things between here, probably. This is the linear velocity of the body. It tells us the current velocity of the body, because this is a physics object. It wants to interact with the world, with gravity and all the fun things. So the question is, how and where do I want to apply this? Okay, let's just make some imaginary code here. Horizontal movement. Force, I guess. What do we need? I have no idea. But okay, let's just try something. If my directional force, which is now direction, if my direction is left somehow. No, that's not the right way. Okay. If it is left or right, we have x values. So if you're pressing left or right, you have x values. So if direction x is greater than 0, or how about this? Absolute value of direction s is greater than 0, because then we have something value here. Something. If I could type, that would be nice. Am I missing something there? Yeah, we're gonna undo this too as well. Remove that one. And lastly, we're setting the force. Let me also comment out. But if you're moving now, I have now indicated by this alone, this function alone tells us if we are moving. Pressing left or right, not jumping. Okay, then I want to apply a force. Apply force on X only? Now that's the question, because if you're moving on a diagonal plane, I want to also get Y values. I want to apply Y on top of whatever else we may have. So this is the key. This is where we need to find the angle. Find the angle, which we just happen to be able to do here, I think, if I were to use the player raycast 2D, which currently... How did I use this? It's been a while since I've used this one. I honestly don't remember. Collide with bodies only, yeah. It doesn't have any signals? Let me take a look at this, at the tutorials here. Raycast 2D. Show me an example, please. No examples. Seriously? How the hell? I remember having used this before. I just don't remember how I used this. Like at all. Oh, maybe I do. Okay, let's try something. Let's just try to call the object. This is a raycast 2D. Collide with bodies. This returns a boolean. Yeah. So if I collide with bodies, which is probably gonna be true in most of the cases, I want to check what that is somehow. How do I do that? Can I like get something? Can I get body or body something? No. Let's find a guide. I'm sure there are guides out there. Raycast the Godot Engine. Where's my drink? There it is. There we go. Ah, tutorials. Excellent. Get to the world space. Okay. What? Get world 2D. Get the right space. What the hell? I don't need space. I need floor. I can get colliders from Raycast. Get collider. Let's try that one. Raycast. It's suddenly silent here. Where's the music? Is the music gone? There we go. Okay, that's a good point. Thank you. Collided. How do I get it though? Doesn't tell me. Collision. Give me the thing. Get collider. There it is. Okay, that's something that kind of bothers me. Oh, there it is. Never mind. Never mind. Okay, I want to check what the group this is. I can use this one actually in the rapid ground. Ground detected. Let's see if this works. It's gonna loop probably now if this works. Oops, it didn't work. I broke something. Apparently, the collider object doesn't have a get groups function, which means it may be a certain type. What type are we getting? Object. Oof. That can be anything. If raycast, you have to detect if we're colliding first, else you get an error. First call raycast is colliding, then call raycast collide or with bodies or get collider. Raycast collide or get collider? Can you get something else from that? Let me see. Get collider returns the first object that ray intersects. If null or no object intersecting is colliding, returns false. Okay, so what? Oh, I'm doing this wrong. Oh my god, I am so bad. Is colliding because what I just used is a boolean to enable or disable collision with body. That's my mistake. Pretty much anything I do here is my mistake, so you know. Okay, if I'm colliding, get the collider. Let's try this again. Maybe that's what's I was wrong, but thank you, I appreciate that. Ooh. Okay, good news, it's not crashing. Bad news, I can't move. It's not printing. Something is not quite here, so let's find out what we are colliding with here. How about this? How about this? What if I run this and move? And print. It's not working. Why? Okay. Because this is not being changed, is it? Print. Direction. Let's try it again. Okay, it is moving. The value is changing rather. But this is not being triggered because the absolute value of x for some reason. Yeah, what is that? That's supposed to be 1 always now. Right? Let me try it again. Double check. It's an X. Try again. Yeah, it's working. 0, 1. When I press left, 0, 1. That's right, 0, 1. So this should work, but for some reason I'm not colliding. Why am I not colliding? Let's see. Let's see. The arrow is a bit big though. I wish I could make it smaller. How do I manipulate this? It is? I don't think that's right. It's not good to scale that. Am I supposed to use a body in here? Or should this be on a... You know what? Let me check this out. It's been a while. I have no idea how to do this. Raise off. I thought it was on. Oh! Thank you for noticing that. Yay! It works! Thank you! You fixed the entire thing. Probably saving me 10 minutes of work. Finding it. Finding that one. So now I'm colliding. This runs. Let's remove that one. Did I get that one? Let's see. Try again. Yeah, ground is detected. Excellent. Now we can do the funny stuff, the good business. We need to get the angle, the angel. The angel. Ground angel. Angle. Let me see. First of all, this is ground. We have verified that this is a ground with this check. Is interacting with the ground collider. Then we know it's a ground. Okay. Give me the angle of this. How do I do that? I don't know. I guess I could calculate the positions, but isn't there a different way? Angle. Maybe there's something I can use. LORP angle. Triangle. Node. Nah, this seems to be anything here. Node. Control node. No. Angle 2. Angle 2. Okay, so I guess I can use vector. Okay, position is gonna be my own position. That position on self. And we need the collider position. Is that gonna work? No, it's not gonna work. Because I'm checking downwards. Can I? Let me take a look. Can I get some information from the colliders? Get collision normal. That's the one. Yes. Collision normal, and then we use the ray cast to the get collision. Okay, so now that's the fun stuff. What am I gonna get from this? This is gonna be a radian. It's gonna be a percentage. I have no idea. I guess I could check the documentation. It returns the vector 2. Okay, it's gonna tell us where the normal is, right? So I need to add this normal to my own, I think. How about this? Rotate by normal. Okay. It's a bit more complicated than what I want it to be. This is vector 3D. Rotation is point A means speed direction. Oh my god. Okay, how about this? Let's Google Godot Engine. Hopefully I get a Godot Engine specific answer here. That would be nice. What's the question? I have FPS control. Oh, this is not the answer I want. Maybe there's a built-in something. So the normal is that x is 0, y is -1. And -1 is up. I think. You see that? It's up, right? Because it goes from top left to bottom right. Yeah, no, is it? Yeah, it's up. Because left is minus. Okay, so now we're getting direction. It's up now. But if I were to somehow move, let me move my player over here and see what happens. Now we have a different normal. Excellent, and that looks better. So now it's pointing away from the ground. But I am pointed directly to the ground. So what I want is, when I apply a force, left or right, this is the ground, this is me. When I apply left or right, I want it to be increased by this amount, or decreased depending on which direction I go. So instead of going this way, I want to add the angle. So I go this way. You know what I mean? So I need to rotate player, or rotate the force rather. And that's hold on, no wait, yes, I need to rotate the normal, because this value is going to be the value I'm going to multiply the force with. Because once I can rotate that arrow away from the ground to be flat with the ground, which means 90 degrees, I will get the vector force, the vector I need rather, not the force, the vector. And then I multiply the vector with the force to create a vector force. Maybe someday I'll utilize this. Someday. Let's see. Where did I... Thinking. Okay, collision normal. Angle, add angle. How to add angle? Angle. How do I rotate an angle? Angle to point. No. Rotate? Rotate? Tangent. Tangent! Yes! Tangent! Yay! I found it! It's here! So now I can use it to tangent. Ah, I have flashbacks from school. Tangent. Cosinus, sinus. I don't know what to name this. Movement vector, maybe. So now let me also print this one, and we'll see how it looks. Let's see. I think that's right. The X is almost, yeah, it's almost that way. Yeah. So the X is pointing left now. Right? Yeah, left. The Y is pointed slightly upwards, like half. Huh? No, it's pointed upwards. I don't know. I have no clue. Let's just try to add the force. See what happens. Movement vector. Let's apply the vector here. See what happens. Copy this one. So the movement vector multiplied by a force. What force should be? Let's say 500. Let's see what happens. And the direction. Within the direction. To whatever direction we're going. Right? Wait. Yes, maybe. No. Okay, normally when I press left or right, I add X or retract from X by going left or right. Horizontally. So what I need to do is I calculate the force and rotate the force instead. Right? First calculate force, because I want the force to be the same. Whether they're going diagonal or not, I want to have the same force. So that makes sense. First calculate the force. Okay, let's try that. Let me copy this again. Okay. This is the force. This is the value you want when you go diagonally, which is not going to work right now. It's not going to work at all. Why? What's wrong? Directional force doesn't exist because we only have direction now. Currently, this is not correct. Let's see if it runs at least. Okay, it does run, and we are moving now. But right now, you can see the force isn't applied in the correct direction. We want the direction to be with the tangent. So this velocity, I need to rotate. How do I rotate that velocity by a to match something? This logo vector 2 is probably something here. Wasn't there a rotate or rotated phi. The worst thing is, I have done this before. But I didn't write anything down, I think, did I? Angle 2. But I don't want to angle to something. I want to angle to point. Hold on. Returns the angle between two lines connecting the 2 points. Okay. Let's search again. Godot Engine rotate force vector by angle. How to write vector? No. Align rotation with vector. How about that one? Why do people keep using this? Well, I guess I could do that. But I wouldn't... Hold on. Hold on. There may be something to this. There may be something here. Let's see. We have a velocity. This is a vector. Rotate it. If I want to rotate this by a phi, right? It's a value you need to calculate from the either the collision normal or the movement vector. How would I do that? Okay, just for fun, let's see if I try to calculate this by using the collision normal angle. Could that be it? It returns phi, doesn't it? Yeah, in radians. That's phi. What's gonna happen if I do this? I have no clue. Oh no. Pause hop. It does nothing. Okay. Wait a moment. That's because we're not setting this value, are we? Yeah, we're not setting this. Can I get this value, please? Basis transform vector 2D rotated. Yeah, it returns the value. We have to return it, so we have to set it. I'm worried about this. How about now? Oh boy. Oh, I'm flying. So when I press right, I go left. Oh. Okay. 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 How about a negative? How about negative? Other direction. Well, I'm floating. Yeah, no, it's not right. Okay, how about the tangent? I'm just playing around now. I have no clue what I'm doing anymore. Now it's just Wild West coding. How about this? Okay, that's interesting. No, that's not good. Okay, this is the vector. I'm rotating it, but the angle is not correct. Oh, I need to do physics again. Let's see. Oh my god. Well, I mean, I can kind of fly now. Well, maybe not. Yeah, closer to a rocket than a player character. Math is so stupid. Oh. Let's let me find some maths. Hold on. Hold on, wait. Think. We have a normal. That's the first thing we do. We have a normal. We interact with a normal surface. Bam. Using the normal, I want to find the direction we're gonna apply the force. Right? We're gonna apply the force in that direction. Tangent to normal. So left will be this will be rotated by the difference between left and tangent somehow. God. Okay, let's do a lot of printing. You know, hold on a moment. I can do rad to degree and see what we get. And print this out. This is going to be the collision normal in degrees. Right? Let's see what we're gonna get from this. Nothing here apparently. Let me comment that out. But again, okay. That why is it not working? I'm missing another one. Oh, Jesus, too many. There we go. Okay. Collision normal in degrees is -90. Now this is correct, right? Yeah, because it goes directly upwards. So when I go here, it should change. Now the angle is not just upward a little bit, but a little more, a little more towards the left on the screen. And that's correct. That's the normal. That's normal. That's what we want, right? But it's not what we want. This is just the degrees we're currently working with. But in a way, what I really want is I want to get the difference. Right now, we're not getting the difference. So when you're on a flat ground, ideally, I would just want 0 degrees, because there's a 0 degrees change you need to do, right? So as you move on the diagonal plane, you will have that value plus 90, which we reduce the 90 difference, so it's 0 by default, and then we have a difference, right? So then I can rotate by that amount, and it should be correct. So I want this to be 0 when we are on the flat ground. Let's see if we can do that. Ideal collision normal in degrees, and that is the collision angle. I think we're gonna minus 90 degrees, right? Or is it plus 90 degrees? I think it's plus 90 degrees. So that means, Jesus, this is the print, this is the string. So here, right? Angle plus dig to rad 90. Hopefully that's going to return 0 now when we are on the flat ground. It's not. It is! Yay! Minus 0.000003, but that's close enough to 0, so I'll approve that. So we have our value now that we can use. Let me double check on here what's happening here. Now the difference is minus 26 degrees towards the left, because we rotate with the left. So this value should be the rotation we need. Vector. Normal. I don't know what the name is. Rotation in degrees. I don't know. Maybe. Let's remove the string wrapper around that. We're gonna fix that later up so we can understand what the hell's going on here without looking at the code too much. Do I have too many here? I think I do, don't I? Oh, I see. Collision normal. This is the radian to degree. This is a radian. Plus another radian, which is 90 degrees. Then we get the result in radian. In degrees. But we need radian, right? And if that's the case, I don't need that. I can just do this. And then we have rotation in radian, which is the standard for calculating rotation and whatnot. Not radian. Was it radian? Is that right? Yeah, radian. And then here's hopefully the movement of truth. The moment of truth. Velocity equals movement velocity rotated rotation in radian, and hopefully that's gonna be correct. I don't know. Okay, on the bright side, we are moving correctly horizontally. Oh Jesus! Oh jeez! Up! Wait! Up! I'm a bouncy rabbit. I don't know why this is happening. Apparently I'm flying. Okay. Okay, what if I negative? Just to try negative and see what happens. Well, now when I go left, I'm jumping. When I go horizontally, it works. But not here. Not here. That doesn't work. No. I have no idea what's going on. Let me remove this comment right there. So this is the correct degree change, but it's not correct anyway for some reason. Let's take a look at radian again. Rotated. It takes in a phi. Returns the vector rotated by 5 degrees radian. Right? I'm rotating that degrees, right? Okay, let's right. Moment velocity angle is rad to degree, which is going to be this angle. Then I'm going to do the same one, but this is going to be the norm. Post movement velocity angle, which will be this value right there. So let me move that down by alt downing it a bit so it goes down, and put that value in here, which it already is, and see what happens. What are we gonna get? Oh boy. Okay, so movement velocity angle before our change is negative. Hold on, something is wrong. It shouldn't be that. Should it? It should be a 180 or something. Really? Hello, Glenn. Thank you. Is my connection slow? Let me take a look here. Do I have I don't know. I can't see anything that's running in the background, so I don't know. Let's let me move this over here and take a look. Just in case. Network traffic 2%. Doesn't seem to be very active right now. Performance seems fine. Wi-Fi. I'll keep an eye on it though. Thank you for letting me know. And we'll see if I can fix that if it becomes an issue in the future as well. Let's see. Movement velocity angle is apparently this somehow. I don't know why, but that's what it is. Yeah, this is before I change this, right? Let me move this up. Move this down. Now this is gonna run like it did before, but I'm gonna add some extra logging to see if it. Yeah, the angle is currently 180 right now, and that is pretty much what's expected. And 0 is just towards the right on the screen. But that's interesting. Oh, it's because of it's because of the way you calculate this, isn't it? Yeah, we need to change this like a lot. Oh, yeah, that's why, isn't it? Okay, let's forget this exists for a moment. Comment this out. And let's redo this. For now, let's just add direction and add a force to that. 100, I don't know. What's gonna happen now? Well, it works. Although it's not very pretty sight. Oh boy. So now my velocity is being directly set by this value, which is why the gravity isn't quite affected. And the reason we use the state, the body state, its current line of velocity, is because it already has gravity baked into it, pretty much. So let's get the velocity. Linear velocity. Alright. And I'm gonna plus the direction force value. Oh boy! Up, jump, too fast. Stop. Stop. Let's try 2. Too small. Okay, how about 40? It works. Now, keep in mind there is no stop. It's gonna accelerate forever, probably, maybe. Oh boy. Stop. Can I make this bigger a bit? Maybe a little bit. Oh boy. Oh boy. Why can't that? There we go. This is more. I'm bothered by this though. Crap. Where's the solid ground? There it is. And the top. Okay, now. Oh. It's okay now. But yeah, I'm stopping now because the force is applied to the right so much that it's just getting stuck. There's not enough upward force. But you can see it accelerates, like the velocity increases until it bounces. It kind of stops a little bit. But yeah, it increases indefinitely, it seems. Yeah. And that's the reason I added clamp on a top speed, so when we reach that, we don't accelerate further. Oh boy. Okay, so how are we gonna do this though? I do need, maybe I can use a step to control it a little bit. I don't know. Let's see. Direction. We use the acceleration multiplied by speed, add on top of the velocity of the body right now. And then we make sure to clamp it to make sure it doesn't exceed a certain value. Now what I'm suspecting is that this here ruins the angle calculation when you move. I don't know, but yeah, I'll have to check it out. Okay, so movement velocity angle is -22. Post movement velocity angle is 3. Strange. Yeah, that's so strange. Like I'm so confused. It's because I keep mixing the body in. Yeah, this is a tricky. This is a really tricky situation. This here is what I want to add the change in the direction, not this part here. I think. So whatever value you calculate here, I want this to be part of it. The change in angle. So let's try this. Oh, how am I gonna do that? Ah, crap. Let me think. Setting this one. So this here I need to calculate. The movement force, which is currently hard coded as direction times 25. Let's change this one to be this. So we're rotating the movement force by that angle. And hopefully that should be somewhat correct, maybe, I don't know. Currently the acceleration is out of control, so I need to set a clamp. So after all this, let's see. Okay, it is clamped now to this value. Oh! It did reach the value. Hold on, let me add a longer hill because the actually let me increase the acceleration. Maybe that'll be easier. I guess this will be acceleration. I don't know, 40 or speed or whatever. Okay. Oh, but look, it's looking better now. 188 down, 183 horizontally. It's a little better, not great. It has a little sluggish in the corner right there. It's kind of stopping and kind of going all over the place. Gonna jumping a bit on top. But yeah, look at this. Seems to be correct right now, because when you go down a hill now, you don't fly down. You kind of just go along. So this is a step in the right direction if this is what you want out of your game. Now, once again, I would not ever use Rigid Body 2D for a player controller, ever. I wouldn't. There is... What the hell? Did you see that? It kind of flew up. Oh my god. No. No, it's broken. So the question is, what exactly is broken? Is the direction wrong? Is the angle a bit wrong? Maybe I should revert that. Let's see. If we are getting in the right direction, I'm sure of it. Oh Jesus. Yeah, that's not right. I think it was right the way it was here. But I don't know why, but yeah, why is it flying upwards? That's strange. Huh. I have no clue. I have not a clue, but I'm gonna take a break now. I'm gonna continue this a bit later. And we'll see if we can clean this up and make this work somehow. Let's remove this, remove that. That's too much logging right now. The movement vector tangent is something I'm not using, so let me remove that. Hold on. That's fine, we don't need that. Collision normal, we're using movement speed, movement force. Acceleration. What can I set this to? 5.0. A vehicle, maybe, yeah, but not a player like this. Because who want to play like this? I would not want a player that has acceleration, like takes time to get going. Like, who cares? That's not fun. That's boring, especially in a 2D game. Now, the strange thing is when it goes upwards. Oh, now it's working. Now jumping is not working, but it is moving downwards right now. Oh, you know, that's not too bad. Let's see. It goes down a little bit faster than it's supposed to. And once it hit the edge, it kind of stops before the force realizes that the angle it's on has changed. So when I'm in the corner exactly, I cannot move when I go right. So the acceleration is too small. So what if we increase this to 50? Okay, 50 is better, but I keep kind of flying up for some reason. It may be. Maybe it's because I keep adding my own body velocity, so somehow it keeps going too fast. What if I don't use this? What happens if I don't use this? Let's see. Too slow now, but at least now it looks very controllable. How about 500? Okay. The speed is constant. Oh jeez, I keep flying. Okay, so it does not appear to be the body that keeps doing this. There's definitely an angle issue here. So when I press right, I keep kind of flying up. Okay, that's good to know, because now I can change it back and add the body linear velocity again. But that means the rotation is probably not quite right there. Now what that means, I'm not sure. Rotate it. Let's take a look here. What if I add a minus? Let's see. I did try that before and it didn't work the way you wanted to. Rotation in degree. Let's see. Change of rotation in degrees. In degrees. Let's see what we get. Okay, so here, why are we getting minus 50? Because we are rotating the movement force, right? That's strange. Isn't that strange? I feel like that's strange. I feel like we're pointing downwards now, aren't we? And that would make sense why it's kind of going more than expected here, if that's the case. Wait, now it's 80. Wait a moment. I'm printing too much information here. Remove this. And let's remove this part and see what we get. Hold on. Movement force rotated by in the radian. What happens if I do this? Hello, Sigit, welcome. Apparently that's completely wrong. When I press left, I go up. When I press left, I go nowhere. If I press right, I go up. Down, there's nothing. Up, there's nothing. Yeah, that's not right at all. Okay, I think there's something to this part. That's how about minus? What happens then? Oh boy. When I press left, I go right. When I press right, I go left. That is very interesting. And the degrees is still 50 and minus 50. Now why that is, I don't know. That's really strange. Collision, normal, angle, returns. The vector's angle with respect to the positive x or in radians. Strange. Very strange. So if we add this to return that back to 90 degrees. What 90 degrees? Why is it 50 though? Here 40. Why is it only 40? Oh. I expect 90 degrees, so the difference seems to be 40. Seems to be 40. Let me see. What are there any special values here? 90 minus 40, 90 plus 40. Strange. Collision angle on the ground. This returns upwards direction, which is 0 minus 1. Which is upwards. Then I add a degree. Isn't this? No, why is it? Oh, that's why. Angle. It returns radians. Radian. Yeah. degrees to radian, 90 degrees. Then I get result of... What's the result of this? It should be 0, I think. Also get this in degrees, just in case. Take a look. Rad 2 deg. Alright, let's see what we are logging. Okay. Rotation in radian is 0. Minus 0. That's fine. In degrees, it changes between minus 0.000003. And that's pretty much it. Yes. But that means... Yeah, we're not rotating anywhere when we are on flat ground. That's what we want. But when we go on diagonally, I want the rotation to happen. But not to that extreme as make us fly and jump in the air like this while I press right. That makes sense. So, something is afoot here. The degrees is negative 26. Yeah, it rotates this much, 26 degrees, like this, in a negative direction, which is counterclockwise, I believe. So I want to apply that negative on the force, which is currently horizontal. I want to apply it so it goes, instead of that way, I want to go this way, rotate the force that way. But for some reason, it's not right. And when I log here, the change of rotation in degrees. Change of rotation in degrees. Is it degrees? Hold on, it's not degrees, is it? What the hell? Hold on. It's radian. It's a vector. This is a vector. It's not a degree. What am I doing? I need to add an angle on this one. Okay, how about this? Add something, forget something. Too many. Undo. Rotated there, I think. Okay, now it's the angle, but this is not degrees. This is rad 2 degrees. Now it's degrees. It's very difficult to read this code though, that's for sure. Okay, so what's going on? Okay, now we can see something here. Change in rotation in degrees. There, I guess it's not change, but it's just the rotation. Current direction. Yeah. Current movement direction in degrees is what this is. Should be at least. So when I go left, the current... So many logging. Let me comment on that. And again, okay, I go left. Now we see... Yeah, this is right, I think. Because we're going left. Then I expect 180. When I go right, I expect 0. That's correct, yes. So when I go right and up a little bit, I expect 25 now, ish. 26, it's right. But for some reason, I'm flying. I don't know why. So the math adds up here. That's why when I go left, when I go left, it's perfect. I don't jump, I just go directly. I just flow along the path, as you would expect. But when going upwards, I kind of get a bouncy bounce effect, and that's not a good thing, no. So what is wrong? I have no idea. I may have to go back to this at some point. But for now, I need to end the stream, and I'll see if I get some time to do some more work later. And that may or may not be good, though. It may be something completely different. I have some development projects I need to do a little bit more work on, which involves DevOps, setting up servers, maintaining servers, working with Jenkins, Java, whatever. Front end, Vue. We'll see. We will see. I need to find a way to make this work a little better, because right now it's to do fix floaty movement when moving upwards. But we know this is correct now. At least the rotation, the force is correct. The force we apply now. Oh, wait. But this velocity here also has a upwards vector, which means we're getting a little more force than we normally would. Which means maybe I need to rotate the sum of this. Maybe. Let's try this one before I end this here. Movement force, do this. This one. What happens if I do this? What happens? Tell me. Oh, so slow. Okay, not quite right. Oh boy. Spazzing out. No, we're done. Done for today. Thank you all for joining today. I'm gonna do some more streaming later. I don't know if it's gonna be today or another day, but you know, small steps at a time, I guess. So until then, have a nice day. Enjoy your last remaining hours of the weekend of Sunday. Bye bye. I'll miss you. Bye bye.